Hi friends, welcome to today's video in our binary tree series. I'm Chinyelu, a software engineer at Microsoft in Dublin, Ireland. Today we'll be learning binary tree traversal. This topic is very important because all binary tree algorithm questions require you to traverse a given binary tree to find something. So grab your laptops and let's get started. Traversing a tree means processing the data of its nodes exactly once in a specific order. Since a binary tree is a special type of graph, it also has two ways of traversal, namely the breadth first search and the depth first search. To learn more about graphs, you should check out our video on the introduction to graphs. The breadth first search approach is also called level order traversal, and it involves processing the data in the nodes of a tree by moving in a level by level fashion. You can achieve this using a queue in the following way. Create a queue containing the root node. Loop while queue is not empty, and dequeue a node from the queue and assign it to a variable current node. Print the value of this current node and enqueue its children. Using this binary tree, for example, let's see how this algorithm will print its node's value. So we first start by creating the queue containing the root node, which is A. Then, while queue is not empty, we dequeue a node, which is node A, and assign it to a variable current node. Then we print the value and enqueue its children, which are nodes B and C. The queue at this point is not empty, so the loop continues. We dequeue node B and assign it to the variable current node. Then we print its value and enqueue its children. But node B has no children, so there is nothing to enqueue. However, the queue is still not empty, so the loop continues. We dequeue node C and assign it to the variable current node. Then we print its value and enqueue its children, which are nodes D and E. The queue is still not empty, so we dequeue node D and assign it to the variable current node. Then again, we print its value and enqueue its children. But then node D has no children, so there is nothing to enqueue. However, the queue is still not empty, so the loop continues. We dequeue node E and assign it to the variable current node. Then we print its value and enqueue its children. Node E has only one child, which is node F. So we enqueue node F, and because the queue is still not empty, we dequeue node F and assign it to the variable current node. Then we print its value and enqueue its children. But node F has no child, so there is nothing to enqueue. At this point, we can see that our queue is empty, so the loop completes. Very simple. Let's implement this in JavaScript. We create our function called level order, which takes in an input of the tree. Let's create our queue with the root node. While queue is not empty, we dequeue a node and assign it to a variable current node. Then we print the value of this node and we enqueue its children if it exists. So if the left child exists, we enqueue it. If the right child exists, we enqueue it. Finito! The time complexity of this solution is O of n, where n is the number of nodes. This is because we visit each node exactly once. The space complexity is O of m, where m is the maximum number of nodes at any level in the binary tree. This is because the algorithm uses a queue to store the nodes at each level. And in the worst case, the queue can contain all nodes in a single level of the tree. Ta-da! This is where we call it a day. In the next video, we will look at the other type of traversal, the depth first search approach. Thank you for watching until this point. If this video was helpful, please give it a thumbs up and hit the subscribe button to see more videos like this in the future. Thanks again and see you in my next video. Bye!